Hi folks, we're still in Module 3 looking at the Novice problems, and now we're going to look at problems 6 and 7. Let's go to our workbook. Here's problem 6. In this particular problem, we're working with the normal distribution, the most commonly known distribution of all mankind, I think. Everyone loves the normal distribution. Why? Well, because it's symmetric. People love symmetry. And it's kind of a unimodal or kind of a humpy sort of distribution. People like that for some reason. And a lot of things do follow the normal distribution or closely approximate or approximated by the normal distribution. So here we have a situation where we have the average weight of a male in the United States being 185 pounds and a standard deviation being 40. I've just selected those numbers out of the air. This average weight probably is much higher. So we're at a local minimum security prison, and we see a group of 25 inmates, and we ask something about those 25 inmates. That is tantamount to doing a sampling, and then asking some questions. That'll be what we do in part 2. So the first thing we do in this problem is we calculate the probability of a randomly selected single male, one person, weighing over 200 pounds. So if you want to look at it from the perspective of a graph, this is what we're looking at. Here's our normal distribution. It has a mean of 185. It has a standard deviation of 40. I haven't placed that there. But what we're interested in is the area from 200 pounds out. And this, of course, extends to infinity. These values become very, very, very small. It's highly unlikely that a person is going to weigh 25,000 pounds, okay? But that's just the nature of the normal distribution. It would include that probability. So this is the area we're interested in. The way that the normal distribution generally works is we calculate areas from the left all the way to the point that we suggest. So from the smallest numbers to the largest numbers. So sometimes we have to manipulate these things, and we're going to have to do some subtraction. Since the area under this curve is all equal to 1, if I can find this area here and subtract it from 1, that will give me the green area. Again, if I can find the area from negative infinity all the way up to the value of interest, that's 200 pounds or less, and then I can subtract that from 1 to get 200 pounds or more. So here is our calculation. The important part of this is the normal distribution, norm.dst 200y. That's our point that we're interested in. 185 is the mean. The standard deviation is 40. And yes, we want cumulative, okay? So we calculate that, and that's really going to give us this area in red. And then we subtract 1 from this from 1 to get our area for the probability of encountering a man weighing 200 pounds or over. And we can see from that calculation that it's about 35.38%. In the next problem, this is where we have the sample of 25 men, and I asked the question, what is the probability of the average of those men being over 200 pounds? So again, I'm going to subtract the calculation that I have from 1, but in this case, I have to modify the norm distribution a little bit. The mean is still 185, but now the standard deviation has changed from 40 to the standard deviation of a single individual divided by the square root of the sample size. In our case, the sample size is conveniently 25, so that will be 40 divided by 5. That gives me 8. And I put true in here to make it cumulative. And again, what I get is all this area in red, and I'm going to subtract it from 1. And we can see from that calculation that the average of those 25 individuals, all taken together, being 200 pounds or greater, is relatively small, only a 3 in 100 chance that that's the case. We'll be working with a normal distribution, and people work with a normal distribution all the time. It's an interesting approximator of reality. By the way, this guy Larry is the guy years and years ago who attached helium balloons to this chair that he was on, and there's a manufacturer now that makes the Larry chair. Larry came to a horrible and untimely end, very troubled individual, but he had his moment of glory. So now let's look at problem 7. In problem 7, we have got a list here of 40 customers that have purchased a product, and the question is asked by an individual is, are millennials, the rate of purchase of millennials different from baby boomers? I'm a baby boomer, a very early baby boomer, 1948. And we like to think that we're different. We're probably not as different as we think, but we can test that. So from this list of, did observation 1 purchase? There are 40 millennials that were shopping. If they didn't purchase, we got a 0. Why? Well, because we use this if statement again. This is why we love this if logic. If L5 is no, then yes, I place a 1 there. If it's something other than yes, I place a 0 there. And you can see that I can copy this down, and at the end of this, we find that our participation rate for this sample of 40 is 25%. So let's create a 95% confidence interval. In other words, in general, what we're saying is I want to pick a range around that 25% that says from this 40 individuals that I just tested, I can be 95% sure that I've captured the true population proportion, the proportion of individuals that are that purchased by building this confidence interval. It's kind of like creating a net. I got 25%, and I'm going to add some to that, and I'm going to subtract some to that, and that net then provides me with a general statement, not exactly, but a general statement that suggests that I'm 95% confident that the participation rate for millennials is between what I've calculated here, 0.115808 and 0.384192, about 11.6% and 38.5%. So how do we do that calculation? Well, the way we do it, according to the book, is that we take our C23, which is this value, the 0.25 that we got, and then we do some magical adjustments to it. We subtract a certain amount to it, and the amounts that we subtract and add will be exactly the same, except in one case it'll be negative, in the other case it'll be positive. And 1.96 is a factor for the 95% confidence interval. If I wanted a 98% confidence interval, this number is going to go up. I need a broader net. Then we take the square root of 0.25, which is our proportion, times 1 minus the proportion, 0.75, and we divide that by the sample size, 40. This is just a formula for how we do this. In this case, the same calculation, 1.96 times the square root of 0.25 times 0.75 divided by 40, but in this case, we're adding it to that to create the range. And you can see that the baby boomers' participation rate, which is known to be 37.5%, is in fact in that confidence interval. So really what we're saying here is that it is possible that the participation rate of millennials is up to 38%. So in this case, I see that the baby boomer rate is really, I cannot make the statement that the baby boomer rate is different from the millennial rate. Why? Well, because the confidence interval captured that rate for millennials, 37.5%. Now, it's probably because this is a sample. If I sampled again, I might find a different result. And being that close, I would want to do that maybe with a larger sample, maybe a sample of 100. Okay. All right, that concludes the problems 6 and 7 in Module 3 Novice Solutions.